Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you an example of how to estimate the standard change in free energy for a reaction at a different temperature other than at 25 degrees Celsius. So in the previous video that I did, we went over this problem here and we calculated the standard free energy change, Gibbs free energy change of this reaction at 25 degrees. And this is the information that we got there. So we calculated the delta H, the standard enthalpy of the reaction to be negative 98.9 kilojoules. We calculated the standard entropy change of the reaction to be negative 94.0 joules per Kelvin. And we then calculated the standard free energy change for the reaction at 25 degrees, and that was negative 70.9 kilojoules. And so what we're going to do here is we're going to estimate what the Gibbs free energy would be at 125 degrees Celsius. And we're going to go ahead and use the same equation we did before. So the standard Gibbs free energy of the reaction is equal to the standard enthalpy of the reaction minus the temperature in Kelvin multiplied by the delta S, the standard entropy of the reaction. So what we're going to do is we're going to put in these values here, and then we're going to put in the new temperature. So again, the new temperature, we have to change that to Kelvin, so it's going to be 125 plus 273, and that's going to be equal to 398. So 398 Kelvin is the new temperature. So we're just going to plug everything in, and that should give us an estimate of what the standard Gibbs free energy of the reaction should be at that temperature. Okay, so this is going to be equal to the delta H of the reaction is here. We're going to change this to joules to match with joules there. So this is going to be negative 98,900 joules. And then minus, and then the temperature is 398. So 398 Kelvin times the standard entropy change of the reaction, which is going to be negative 94 joules per Kelvin. Let me double check to make sure that is correct. 90 negative. Yes, that is correct. Okay, so we're going to write negative 94.0 joules per Kelvin. The Kelvin cancels out. We got things in joules. And so we're going to go ahead and calculate this. And this is going to be negative 61,488. So this will be negative 61,488 joules. And if we, so that is the joules. If you round it to sig figs, negative 61.5 kilojoules. If we compare this with at 25 degrees, the standard enthalpy, you'll notice that it's more negative here than it is here. So it's more spontaneous. This reaction here is more spontaneous at 25 degrees than it is at 125 degrees. And that's how you would estimate the standard Gibbs free energy of a reaction at a temperature other than 25 degrees if you already know what these values are. If you calculate the delta H, standard enthalpy of the reaction, standard entropy of the reaction. I hope this is helpful. If you like this video, please like, share, subscribe. hit the notification bell, leave a comment, and thanks for joining me. I'll see you next time.